Hello! So this is probably the video you've been waiting for. We're going to actually try to make the robot begin to move, okay? But before we do, let's make sure we got some basic setup done. My left servo, all right, is hooked up to pin 0, the very first set you can plug into. My right servo is hooked up to pin 1. I have both servos plugged in with the light colored wire closest to the chip, and the darkest colored wire, black, furthest from the chip. So that becomes signal, power, and ground. I'm currently running this device at the 5 volt setting, okay? So this jumper is in the forward position, not in the VN, but on 5 volts, all right? There's a reason for that. If I run it off of the battery pack, it will go faster. But what we won't be able to do is control the decay of the batteries. Right now, if I run it on 5 volts, if the batteries are running 7 volts or 6.8 volts or 6.5 volts, it's still going to be 5 volts going to the motors, all right, as the batteries die. If I run it on VN, as those batteries die, the voltage available to power to the motors is going to decay. And what you're going to see is your robot is no longer going to behave the way you programmed it, because one wheel is always going to be a little different than the other. And as the power drops, you're going to see one wheel slow down faster than the other, and your robot is going to be able to sway. So for precision control, I recommend putting it on the 5 volt supply. This switch, I got it kind of covered with a wire. This switch turns on and off the power to the motors. It turns on and off the power to this side. I'll go ahead and switch it on for the default, because right now I know I'm not signaling anything anyway. So you need a hunk of code, and Chris has written a really nice module, and if you're a George School student, you can get to it easily. It's going to be under Files, it's going to be under Modules for George School students, and what I want you to download is the Servo Motion module. Keep in mind, I want you to only download it. Don't click it, don't run it, just download it and know where it went, because we're going to put that into our sketch. If you are not from the George School, I'm going to have it here under George School sample code at my website under code examples. Okay, so you'll be able to get it from there as well. Let me get this out of the way. So let's go ahead and do it. You can see I've started a sketch, a basic sketch, and there's nothing in here. I've already named it Chapter 19 Work. So now what I'm going to do is I'm going to add a file, and I'm going to add the file that I put in downloads for the Servo module. And let me get down here. There it is, the Servo Motion module. Okay, so now I've got this tab here with this additional module that we can use. This is super important. Copy everything below this into your main sketch and everything above here. Okay, please note that that does include the setup. So I'm going to copy all of this, including the setup, and I'm going to replace the setup and paste it right here. Okay? So please make sure this matches your system. My left servo is on 0, my right servo is on 1. The LED pin from the thing you can't really change, it's on 13. And the first thing it does in the setup is it goes ahead and sets all those pins to output so we can send signals to them. And then it calls the blink program for 3 times. We're going to run blink at the beginning of every download or every start so that we know whether or not your processor is resetting if the batteries go weak. If you see that your LED, your robot's acting erratic, and then suddenly you see the LED flash, well then you know it's because it's actually restarted all the way back to setup. Okay, so erratic behavior followed by flashing of this LED means your batteries are too weak, they're resetting the processor, and you need to charge your batteries. So let's go back over here real quick. And Chris has written a really nice test program. Let's go with this one right here. Motion fast test. I'm just going to copy that, and I'm going to paste it into the loop. Now, I'm going to put semicolon there. I don't want this thing to run over and over and over again. I want to see when it starts and when it ends. So I'm going to do a while true. Okay, clean this code up a little bit. So it runs one time and then it's going to come to a stop. My motors are on, the light is green, the switch is over. I'm going to upload and I'm going to pause this because the first uploads take a while. Okay, so I've loaded at least once. Now remember, the first thing it's going to do when it loads, it's going to flash that light. And there you see it. Now it's going to go forward for 88 steps, switch directions, forward again, switch directions, and the last thing it does is reverse, and then of course it reaches the infinite loop and stops. So let me pause this again and load another piece of code that I want you to play with, and I'll be right back. Okay, so take a look here. I've got this single program, the single function being called forward slow for 500. Okay, what that means is it's going to pulse both of these motors at the relative rates, which we're going to look at here for a second, and it's going to pulse them 500 times. I've made these two marks because I can't really show you very easily the robot driving down a straight path, but we can certainly see whether or not they're rotating at the same rate by watching these lines go by. So if I get them lined up here in the camera, one would expect that if I tell it to go 500 steps that direction forward, all right, they should end up being at the same point when it's done. So let's run it and see what actually happens. Okay, this is 500 steps. And already I think you can see my left wheel is spinning faster than my right wheel. Okay, they're nowhere near aligned. So what we want to do, and I don't recommend putting the marks, I actually recommend doing this on the floor so you can see your robot actually moving down a path. So what I'm going to have to do is change the rate of one wheel versus the other. Let me play a little bit with it on pause and I'll see if I can zoom in on the issue. Hold on one second. Okay, so I'm calling forward slow 500, okay? Which means that I'm actually doing is I'm calling this application right here, and it's calling the forward step slow, all right? And forward step slow is here, and what it's doing is it's calling these two, or referencing these two arguments here, the left forward slow and the right forward slow. Okay, well, what are those? Those are these numbers here. Okay, my left wheel is moving faster than my right wheel. Remember, 1500 is a dead stop. Okay, so I want to do is I want to slow down my left wheel. I don't want it to go as quick. So let's get it closer to 1500. We're at 1600. We need to get closer to 1500. Let's try going, say, 1575. Or 15, yeah, we'll go 1575. All right, and see what happens. So now I've slowed this wheel down a little bit, and then we'll see if we're any closer. That just passed. Yeah, we're still off, okay? So let's go down even a little bit lower. Let's go to 1550. We can also speed up the other wheel, obviously. So let's not get too carried away, but we'll try 1550 and see if we can get these two to line up a little bit better. Well, that's certainly slower. We don't have to go near as far to go back to that spot. I'm going to go ahead and speed up the right wheel. Okay, so the right forward slow is at 1400. We want to go further away from 1500. So let's make that, we're going to get closer to 1000. So let's make that 1380. You can see that this could take a while, and I'm not going to wait. I'm not going to make you guys wait for me to get it perfect. So I'm speeding up the right wheel, getting closer to 1000. Well, let's go a little bit further. Let's make that 1350. And I just realized that this thing was not resetting all the time. Something to watch out for, okay? So we probably passed our point closer to here because I was not hitting the reset button. So if I hit reset and then load, we'll probably get a better run with it. Now that one's really slow. Looks like we got to speed that one up. Okay, hold on a second. I'm going to pause it and play with it for just a second. All right, so I've been playing with these two. I've adjusted a couple of things. It's not quite perfect, but it's pretty good. I'm trying to get it to go straight, so these two marks should end up being about kind of where they were at the same point as rotation. So I'm going to bring that one back a little bit. And the other thing I've done here is I've lowered this number here so it actually rotates only one time. So if I load this up, you'll notice I've been playing with just the left forward slow on both the right and left wheel. Okay, and I'm going to load it up, and what we should see is it come back to pretty close to the same point, or at least aligned with each other. They'll probably be off by maybe, I don't know, a centimeter or something like that. But you can imagine if this robot was rolling down the table, that would be pretty straight. Okay, I'm pretty happy with that. That's a nice straight motion. So then you would save this information for your robot. You need to save it so that you can always reproducibly make your robot go straight, slow. You'd also want to do the same thing for fast, by the way. Keep in mind that you can't go in really any higher than 2000, and you can't really go any lower than 1000. So you'd have to actually adjust one wheel dependent on the other. So if the left wheel is going too fast, or faster than the right, don't try to speed up the right, try to slow down the left. And then it should all work out just fine. So let me pause this and set up the next thing, and I'll see you in a second. Okay, so once you've actually set all of your positions and speeds so that your robot actually does go straight, and you understand how many pulses it takes to turn left and turn right, now it's time you can actually create your own sort of custom program. So let's say you had, for example, to navigate around an obstacle and then turn, 360 degrees around it, drive forward, come back to the same spot. You would just do nothing more than copy and paste these blocks of code and add the appropriate numbers of steps. Okay? So in this case, I have mine going forward fast for 100, left slow for 100. I can mix these up, by the way, of course. Forward fast for 200, right slow for 200, and then right reverse for 100. So when I load it up, you'll see that it does just that. Okay? It goes forward, wait for the flash, goes forward, turns left, goes forward again for 200, turns right slowly, and it does a reverse. Okay? Now, it's also important to realize that now is the time to consider untethering your robot. So in theory, you simply turn it on, it starts flashing the light, and it will, in fact, run the program, and you can drive it around untethered. Okay? So hopefully that was informative, and I'll see you guys again soon.